Now, as I promised, we're going to take a look at one of the questions that came up in previous years in relation to what did they ask about the preparation of ethene. And just remember, you will be having a test on this when I finish ethyne tomorrow. So I'm going to do ethyne tomorrow, and then I'm going to finish off tomorrow by giving you a test on ethene and ethyne. Now, I know we don't normally have 50-year chemistry on a Friday in school, but I'm a little bit behind, and I want to use tomorrow just to catch up. So let's take a look at the question. It's very, very easy to recognise what we call an ethene question because of the apparatus itself. The apparatus is quite familiar. There you have your horizontal boiling tube. There you have your powder. There you have your glass wool and your ethanol. There you have your delivery tube. There you have your bubbles of gas. And there you're collecting your ethene. So just to take a look at the questions, because the questions are quite straightforward and there's a lot of marks going for them in this case here. So what is the function of the glass wool? And then they want you to identify the solid and describe its appearance. Now, what's the function of the glass wool? The function of the glass wool is simply to hold the ethanol in place. So it can't use cotton wool because it would burn. So we use glass wool because it can withstand the high temperatures. So therefore, the function of the glass wool is simply to hold the ethanol in place. That's all it does. If we didn't have the glass wool and we tried to keep the ethanol down here as a liquid, it would pour up here and it would destroy the catalyst. So we can't have that. So it simply holds it in place. Identify the solid X and describe its appearance. Now, we haven't, unfortunately, managed to do this experiment in the lab, but what you notice is X is aluminium. We had this already. Oxide. And aluminium oxide is a white powder. White powder. And you'll notice that it's dry, very dry when it goes in there, but it actually goes a little bit darker. As the reaction proceeds, it goes a little bit darker. What does it do? Now, I know the question doesn't ask you that, but what does this aluminium oxide do, this white powder? It acts as a catalyst, just in case you were asked. And that simply means that it helps to speed up the dehydration of this particular alcohol into this particular alkene. Okay, so part B. State and explain 2 safety precautions which should be observed when carrying out the student experiment. Well, I suppose the most important one is the one I told you about in the previous video, and that is that when the reaction is finished and when you have collected all your ethene gas, the temptation is to remove the heat. But if you remove the heat, all of a sudden the gas in here starts to contract quite quickly, which means it's going to pull the water up the delivery tube the wrong way into the hot glass, cold water, hot glass. You'll get this glass which will crack, and crack very badly, probably explode because of the heat of the glass that's there, but I don't want to be too dramatic. So the cold water will get pulled up in here. So 2 safety precautions which should be observed when carrying out the student experiment. Well, number 1, you wear your goggles. That's always going to be a safety experiment. So wear goggles. And number 2, you remove the heat before the boiling tube, or the delivery tube, I should say, delivery tube. Oopsie daisy, before the delivery tube. Okay, and that just makes sure that you don't get what we call suckback. Okay, part C. Write a balanced equation for the reaction involved in this preparation. Now, again, if you go back to the previous video I gave you, the preparation itself is called the dehydration of ethanol. That's the name of the thing. It's called the dehydration of ethanol. Now, what does that look like? Well, ethanol is C2H5OH. And what we're going to do is simply pass it over hot aluminium oxide. That's going to remove water. Remember, dehydration. And what happens when you remove water? Well, you remove these, and you also remove one of these 5 hydrogens, which simply leaves you with, excuse me for that, C2H4. So C2H4, that's it. So that's all you've got to remember. C2H5OH passed over hot aluminium oxide catalyst, removes water, and then you can go back to this molecule here, take off that H, take off that O, take off one of those 5 H's, and what are you left with? You're left with nothing more than C2H4. Let me just write that again for you, it's a bit awkward. C2H4. And that is ethene. Okay, part D. If the ethene produced is bubbled through an acidified solution of potassium permanganate. Now, I spoke to you about this in the previous video already. Potassium permanganate is a dark purple colour, and when it's acidified it becomes very active potassium permanganate. So we always add in a few drops of sulfuric acid just to kickstart the potassium permanganate so that it acts at its best. So if the ethene produces bubbles through an acidified solution of potassium permanganate, the solution is discolorized, showing that the ethene is unsaturated. There's that word again. What is meant by the term unsaturated? Well, unsaturated means the presence of a double or a triple bond. It also means, you can be a little bit more kind of vocal on that. You could say, well, it's a molecule that's able to hold more hydrogen, but I think it's far better just to simply say an unsaturated molecule is one that contains a double or a triply bonded carbon. So unsaturated simply means the presence of C double bond C or C triple bond C. Yeah, one of those. I don't know why that keeps doing that. Anyway, describe how you would carry out another test to confirm that the ethene is unsaturated. Now, there is only one other test, and it is a decolorization test, because when we add in the ethene to the acidified solution of potassium permanganate, notice it says the solution is decolorized. Okay, there's only one other test we have that's also a decolorization experiment, and that is taking your ethene. I don't know what's wrong with this thing at the moment. Taking your ethene, let's try that again, and bubbling it through what we call bromine water, which is yellow. And bromine water, being yellow, when the ethene passes through it, becomes colourless. It goes from yellow to colourless. Okay, and that's the only other one we have. So therefore, there are two decolorization experiments. Bubble ethene through acidified potassium permanganate, goes from purple to colourless. Bubble ethene through bromine water, it goes from yellow to colourless. And both of them are proof that the ethene molecule is unsaturated. Okay, so the last question, part E. Describe the flame that would be observed when a combustion test is carried out on a sample of ethene. Now, a combustion test means you burn it. Okay, and then it says write a balanced equation for the combustion of ethene in excess oxygen. Okay, well, first of all, describe the flame. Now, again, I gave you the video. You can see the flame. Please, please, please watch these videos. They're there for your own learning. Watch them and see how the flame burns. It burns what we would say cleanly. Apologies for this. It burns cleanly with a luminous means bright, a luminous flame, but there's not too much soot at all. So it burns cleanly with a luminous flame. That's how we would describe that. And then it says, write a balanced equation for the combustion of ethene. So you take your ethene molecule, C2H4, you're going to combust it with oxygen. That's what combustion means, mixing it with oxygen. Now please remember, every single time you burn a hydrocarbon in oxygen, there are only two products, carbon dioxide and water. That's all. But we have to balance this thing, and they always expect a good chemist to be able to balance the reaction. So look at the left hand side, 2 carbons, right hand side 1 carbon. Doesn't agree with the law of conservation of mass, so we put a 2 in front of that. Not like that, because that's a little bit silly, but like this. So you put a 2 in front of the CO2 like that to balance up the carbons. Then we have 4 hydrogens, and we've only got 2 here, so another 2 goes in front of that. And at the same time then, these 2 oxygens are doubled, that's 4, and this oxygen is doubled, that's 6. So to bring that up to 6, I put a 3 in front of that, and that's the balanced equation. They cannot ask you anything else in terms of ethene gas or its preparation outside of those questions.